Hopefully you've taken a systems analysis and design course. Several are offered here at Drexel. Most colleges have systems analysis and design where you talk about the software development lifecycle. So typically a software development lifecycle is how you can develop anything. It could be an application that you're developing, or it could be a system. So SDLC can also be a systems development lifecycle. It could be developing some infrastructure, anything where you have to do some analysis, requirements gathering, planning, designing, and then implementation. And that's generally the steps. We start with defining exactly what our problem is, gathering requirements, designing our solution. We develop our solution. We test to make sure it works. And that's pretty much it. So it's a pretty basic, but it's a structured way to go through a project to ensure that you're meeting the needs of the users and that you're developing a system that's going to work. In the cloud, we sort of do the same thing, right? We follow the same process just like we would in any other IT-based project where we're defining our requirements, gathering our requirements, and doing our analysis, then doing our design, developing our product, and then we test it and deploy it. So we follow that same structure. One of the things that your book talks about in this course, well, I don't know if your book talks about this per se, but the cloud security professional Cloud Security Professional Certification Exam brings this up, which is Puppet and Chef, which these were, so Puppet was kind of a, and these really kind of got popularized around 2012, maybe about 5 to 6 years ago from when I'm recording this video. And they've already sort of been replaced by other technologies. But the idea was that with something like Puppet, you could, or with protocols and open source tools that use Puppet and Chef, you could automate the configuration of systems. You could take the state of your infrastructure and then you could automatically enforce that infrastructure going forward. With Chef, you could automatically deploy or build application environments, and then you could deploy them from recipes. It was the basic idea, and the goals here were dynamic analysis, vulnerability assessments, and pen testing was a lot easier. You could do activity monitoring, implement these with layer 7 firewalls, and so forth. So what's largely replaced the concept of Puppet and Chef is things like Docker. And you can certainly look that up online, but Docker is a platform where you can basically create these containers of so let's say you develop an application and it has lots of different components, right? So it might have a little web server, it might have some data structure that it manages to a database engine or something like that. And maybe even Java or something like that, or a runtime environment or a compiled code, who knows? But they could have all of these different components. Anytime you develop software, it's a collection of these different components. And that's really the backbone of how modern IT works, right? We no longer develop these monolithic systems that are a single system that or a monolithic system, I should say, that has all of these components that, instead, rather, today we have all these different components that we can utilize instead of building all that stuff from scratch. So, for example, nobody develops their own database anymore. We instead use a database engine to store our data structures and to work with our persistent data. So, what Docker does is if you develop an application that uses all these different components, you can sort of build that environment, and then you can capture that and sort of encase it in a container that can be deployed as a container. And what does this have to do with the cloud? Well, I'll explain. In the cloud, what we want is the maximum application density. So we want to take advantage of the hardware that we're using as much as we can. We don't want to have single applications running on in an instance of a VM, for example, that isn't fully utilizing all of the potential resources that are available through that through that virtual resource. So what we could do with containers is, let's say we have an application we want to deploy, but maybe each customer needs to have their own runtime of that application. Instead of having their runtime running on a single VM, I could have one VM with hundreds of runtimes, all in their own containers. So they're all containerized, running in their own containers, and now I can take advantage of my resources much more efficiently by sharing them and having all these containers running within that resource. I probably didn't do that justice, the explanation, but that's basically what something like Docker does for us. And that's quickly becoming sort of a de facto standard for application deployment. So I think even though in this course it's not an official objective to understand Docker, I would highly recommend for the industry that you take a look at something like Docker. There are other solutions out there, but Docker seems to be the de facto standard now. That's what most people seem to be using in the industry. So definitely something worth taking a look at. And then finally, when we deploy applications, at some point we have to dispose of those when they're no longer needed. And we've talked about crypto shredding before, which is deletion of the encryption keys so that no one can access that data any longer. So that's basically the cycle, the software development life cycle. So again, when we're deploying our applications to the cloud, we want to consider the SDLC just like we would with standard applications and deployments within our own infrastructure. But pay obviously close attention to some of the special concerns with the cloud. And then we have these other technologies, which your book talks about, Puppet and Chef, but things like Docker that are available to us for deployment. And then finally, after we deploy at some point, we probably have to dispose of these applications when they're no longer used, and make sure we can handle the disposal of that data as well, which we talked about previously in our data management section of this course.